Lesson 84, Degree of Equations, Solutions to Systems of Equations. Okay, the degree of a term of a polynomial is the sum of the exponents of the variables of the term. So 2 is a 0 degree term because it has no exponents. X cubed is a 3rd degree term, exponent is 3. This one is a 5th degree term because we have 2 is an exponent, and then y's exponent is 1, m's exponent is 1, p's exponent is 1. So 2 plus 1 plus 1 plus 1 is 5. In this one, we have a 1st degree term because anything with a variable would be an assumed 1. Okay, 2 doesn't have a variable, that's why it has 0 exponents. The degree of a polynomial is the same as its highest degree term. The degree of a polynomial equation is also the same as its highest degree term. So 3x squared plus 2x plus 5 is a 2nd degree polynomial. 3x cubed plus 2x squared plus 3 equals 0 is a 3rd degree. Xy plus 5 2nd degree. Y equals 3x plus 2 is a 1st degree. And thus far we've restricted our equation solving to 1st and 2nd degree polynomials. 1st degree equations and 2 or more unknowns are called linear equations because the graph of a 1st degree equation is a straight line. So the equation 3y plus 2x equals 4 is a 1st degree polynomial equation and 2 unknowns. And we can graph these and we get a straight line following our format of y equals mx plus b. Okay, so applying that to solutions to systems of equations. When we have a system of 2 linear equations and 2 unknowns, there are 3 possibilities for the number of solutions to the system. The first is that the equations have one common solution. So that's this one. They intersect at one point. We have a line going this way, a line going this way. This is the only place they intersect. Each line in this example has an infinite number of ordered pairs that satisfy its equation, but only one ordered pair satisfied both equations and thus lies on both lines. So I could have lines or points going all the way out to here or all the way out to here, but this is the only point where these 2 particular lines intersect. Okay, in example B, the 2 equations have the same graph. So the coordinates of any point that satisfies one of these equations satisfy the other equation. So in this second case, both equations are satisfied by an infinite number of coordinates. Doesn't matter how far out we go, they're all the same line. And then the third possibility is that the lines have 0 common solutions, and you should recognize these 2 lines here as parallel. This happens when the lines have the same slope, and remember, same slope means parallel, perpendicular, opposite. If you look over here, these are perpendicular because they have the reciprocal of opposite signs. Okay, so in this example of C, no points are in common, no matter how infinitely we go. So we summarize the 3 possibilities below. Number 1, the lines cross and thus have 1 point in common. Number 2, the lines overlap because the equations describe the same line. And number 3, the lines are parallel and have different intercepts, so they have no points in common. If a system has one solution, the lines will cross and the system can be solved by graphing or by using the substitution method or the elimination method. An attempt to solve a system with infinitely many solutions produces a true numerical statement, one devoid of variables such as 0 equals 0 or 5 equals 5. All right, we demonstrate by trying to solve system B using both substitution and elimination. So system B here. 2... Okay, we're substituting, so we have a y equals 2 times x minus 2 equals 2x minus 4. 2x minus 4 equals 2x minus 4 divided by 2, 0 equals 0. Then we could do it with elimination. Okay, they're plugging 2 in, -1, 0 equals 0. A system of 2 equations whose graphs are parallel has no solution, so an attempt to solve one of these systems will fail. The variables can be eliminated, but the result will be a false numerical statement such as 0 equals 5 or -3 equals 7. We demonstrate by trying to find a solution for system C which does not have any points where it crosses. So if we plugged in, okay, y equals, so 2x minus 2 equals 2x plus 2, and then we get rid of our 2x's, negative 2 equals positive 2. That doesn't work. Here, if you use elimination, 0 equals negative 4. That doesn't work. A system of equations that has at least one solution common to all equations in the system is called a consistent system. Thus, system A and B are consistent systems. A system with no solution is called an inconsistent system. System C is an example of an inconsistent system. A system of equations is a dependent system when one of the equations in the system contains all solutions common to all other equations in the system. Otherwise, the system is an independent system. So systems A and C are independent systems, and system B is a dependent system. In summary, system A has one solution. It is both consistent and independent. System B has infinitely many solutions. It is consistent and dependent. And system C is inconsistent and independent. It has no solutions. Okay, so we will work on those, putting those into practice in problem set 84.